It's getting to be galaxy hunting season.
Mm-hmm.
Really nice.
And well, next month, I'm keen to set up the next star party next month, middle of the month. We'll talk about that later. But our own Milky Way galaxy, the dust, stars, and gas galaxy of Milky Way will be down our own horizon. So if we look up, we'll have this extravagant menu of other galaxies to look at. We'll have the Virgo cluster, the Leo galaxies. But now we take it for granted that we know those other spiral nebula in the sky are other island universes like our own Milky Way. This was not always the case. There was a time when astronomers wondered, why are those spiral nebulae only up there outside the disk of the galaxy and not within the disk of the galaxy? This kind of discovery of why that is, those that supported it and those that followed, were part of a path of inquiry that led to some profound insights about how big the universe and what it is. And that path of inquiry is what's recounted in the book, The Day We Found the Universe. And we're very fortunate tonight to have the author of that book with us to talk about that. Marcia Bartusiak is, with a very long title, a professor of the practice Emeritus in the graduate program in science writing at MIT. She has degrees in physics and communication, author of several books, including the one we'll hear about tonight, Black Hole, Universe Darkly, and several others. So take a moment, please. Let's silence our devices. And then please join me in extending a warm welcome to Marcia Bartusiak.
Thank you very much. Let me get my tools in hand. Okay. As Dean pointed out, the idea that the Milky Way was not alone is an idea that has a long and checkered history. In fact, it was mentioned in the 18th century. Immanuel Kant, the philosopher, talked about island universes. And the British astronomer William Herschel, also when he was with his telescopes that were the biggest in his day, were seeing all these nebulae, and he was thinking of them as other universes. But by the end of the 19th century, those ideas had gone away, and people were studying the spiraling nebulae in another way. And one of the people who really did this was James Keeler at the Lick Observatory. He was the director of the Lick Observatory at the end of the 19th century. And he made a decision, which was very unique at the time. Astronomers at this time focused on stars and planets, but he decided to really look into these spiraling nebulae and started taking pictures all over the sky and counting them up. And this was an image he took in 1899. And he was starting to circle all the various spiraling nebulae that he was seeing in the sky. But at that time, he was suspecting, as most astronomers were, that these were baby solar systems in the making, which is actually not an unreasonable idea. When you look at this, doesn't it look like there's a sun starting to coalesce and the planetary nebula are starting to form the planets? But by the early 20th century, this idea started to be challenged. Keeler, if he had continued, probably, we might have had the Keeler Space Telescope. He was the world's best spectroscopist. I think he would have figured it out, but unfortunately, he died at a very young age, smoked like a fiend. If you go back and see every picture of him from that era, he's holding a cigar in his hand. he could have been the one who solved the mystery, but unfortunately, when he died, the problem went away for a decade or so until in the 1910s, this man, Heber Curtis, also at Lick Observatory, decided he was going to take up again the idea of the spiraling nebula. And he didn't use the big refractors. Anybody been at the Lick Observatory? This big, beautiful refractor, one of the largest in its day. That was used for other studies. There was a smaller telescope there called the Crossley telescope, which was a mirror. Very unusual in that era to have a mirror telescope rather than a refractor. And he refurbished it. Looks like the gun on a naval battleship. And he decided that he was going to start surveying those spiral nebulae, taking up where Keeler had left off. He was the man who almost discovered the universe. He surveyed the sky for the spiral nebulae, started counting them up, and he estimated that there were at least 1 million of them all over the celestial sphere. Moreover, he really came to believe that they were galaxies. And the reason is, for one, he says, look at that spiraling galaxy edge on. Those dark clouds look just like the dark clouds in our Milky Way. And he also cited novae within them. Of course, you know that novae are when you have the brief and temporary flare-up of a star. And he compared the brightness of those novae to the novae within our own Milky Way, and he concluded that they had to be millions of light years away in order to be so faint. You might ask, well, then why doesn't he get all the credit for discovering other galaxies? Because it was all circumstantial evidence. He needed a slam dunk. He needed a measuring tape right out to those galaxies. And that required a cosmic yardstick that astronomers didn't yet have. But fortunately, in that very decade, there was such a discovery due to this woman, Henrietta Leavitt, at the Harvard College Observatory. She was able to establish a distinct link between the brightness of a variable star known as a Cepheid with its period. The brighter the star, the slower it blinked, as you can see in this demonstration here. So once you calibrated this scale, you could pick out a far-off Cepheid, look at its period, and then you would be able to know its absolute brightness, its intrinsic brightness, as if you were right next to it, from the law that she established, the period luminosity law. And suddenly, because of this, astronomers had a tool to be able to find distances far beyond what they had from other methods like parallax. So instead of just hundreds of light years being able to determine distances, now you could do thousands and more. Well, one of the first ones to use this new tool was Harlow Shapley. This is a man who grew up in Missouri. He actually worked as a crime reporter for a newspaper, went to the University of Missouri intending to major in journalism, but they hadn't started their program yet. He switched to astronomy, and he went on doing very well. He went on to his doctorate at Princeton, and then ended up at the Mount Wilson Observatory in California, then the best and most world-renowned observatory in the world at that time. And he was the one who first put Henrietta Leavitt's rule to work. And he did this by measuring the distances to the many globular clusters that surround the Milky Way. He actually determined the distances to each and every one, 90-some globular clusters that were hovering around the Milky Way like bees around a hive. And by doing this, he saw that the Milky Way was far bigger than anyone had estimated before. In fact, he liked to say that, and also on top of that, he discovered that our sun, let's see, is my little, I guess my little light isn't working. Oh, there it is. There's our sun. He noticed that our sun was not in the center of the Milky Way, as it was long assumed. He did away with that Copernican principle that we were shoved off to the side in the suburbs. As he liked to say, the solar system is off center and consequently man is too. And this was all around 1918. Now, before, our galaxy was estimated to be, 10, maybe 30 at the most, 1,000 light years across. But Shapley determined that it was actually 100,000 light years wide. Well, this was so much bigger that he decided on a certain model of the universe. The Milky Way was the universe. And all those other little spiraling nebulae that you saw, they were just mere appendages that were surrounding the Milky Way. It was his big galaxy model. So by 1920, we then had two models of the universe. There was Shapley with his big galaxy model, and Heber Curtis with the island universes model. In fact, they even had a big debate in 1920 in Washington, D.C. over this. But unfortunately, the evidence at that time, it was very hazy. Each of them had good arguments on both sides. No decision was made. They just couldn't decide between these two models. Now, Curtis, he could have continued with his work at the Lick Observatory and solved this problem. He was smart enough. He had the answer. He just needed more data. But what did he do? He decided to become director of the Allegheny Observatory in Pennsylvania, just outside Pittsburgh. Can you imagine the steel mills at that time blowing all that smoke and dust into the air? And it didn't have the telescopes that Lick Observatory had. But he made that decision because he was a family man and this was a big promotion and this was going to be important for his family. But once he got there, he realized he just who first used the Cepheids to determine the distances to the globulus. He could have gone on and searched, continued his search and discovered the magic formula. But he was mulishly wedded to his vision of the universe, the big galaxy model. And the spirals to him were just minor objects that didn't concern him, and he didn't want to be bothered studying. Well, by then, he went off to Harlow. Whoops. Sorry about that. Shapley went on to become director of the Harvard College Observatory. So in a way, he took himself out of the running as well. But by then, there was no Shapley Space Telescope either. By then, there was a newcomer arriving at Mount Wilson Observatory, straight from serving as an Army major in World War I. The observatory's director, George Ellery Hales, very good for looking out for good people. And he heard about this young man at the University of Chicago at Yerkes Observatory who was doing some good work with his thesis. And he promised him a job once the war ended. And he did show up at Mount Wilson right after the war. But he stood in Shapley's shadow for a while. while Shapley was still there. But once Shapley went off to the directorship at the Harvard College Observatory, Hubble was able to focus on the spiral nebulae all to himself. He had the whole. Did I do something wrong?
You did. Don't worry about it. We're all good. It's all good. Hmm.
I think I did something on the,
Changes.
oh, there we go.
There we go.
Okay. Now, Hubble was a complex man. He was a bit aloof with his colleagues. He didn't really make friends with them very much. His friends, though, saw him as an Adonis. In fact, I always like to think he looks a little like the actor Jeremy Irons when he was young. I've always seen that in this picture. He grew up just like Shapley in Missouri, in the Midwest, strong middle-class roots. His father was in the insurance business.
Oh,
He went to the University of Chicago, hoping to major in astronomy, but his father just put his foot down and says, "You're going to major in law." So he did both. And he did so well that he got a Rhodes Scholarship and went to Oxford University in Great Britain for 3 years. And there he completely transformed himself. He began to speak with a British accent, which he kept the rest of his life, to the dismay of all those people at Mount Wilson who grew up on farmland. He learned to brew a proper cup of tea, wore a cape with great flourish, and he also wore these knickers all the time when he was observing. If you see any pictures of him observing at Mount Wilson, he's wearing these knickers. He's a man who really yearned to be singular and distinct, even adding a bit of dishonest gloss to his resume. He always told everybody that when he came back from Oxford that he worked in the law for a year, which he did not. He never worked in the law. He was actually a high school teacher, taught physics and Spanish at his high school. They loved him. They actually dedicated the yearbook to him. But finally, he decided after that year to go back to the University of Chicago to major in astronomy. And that's where he first became fascinated with the spiral nebulae. And he decided that was going to be the subject of his thesis. So he completed his PhD, went to war, and then he showed up at Mount Wilson on September 11th, 1919, just a week after this, the world's biggest telescope at the time, went into full operation. Well, he began using this telescope on Christmas Eve that year, 1919, and he kept this logbook to keep track of all of his observations, page upon page. He told a colleague that he was going to determine the relation of nebulae to the universe. That was his goal. And he did this with single-minded devotion. Year after year, he plugged away, going from target to target. And this is just one of the many pages in the book. And he kept track of his photos. You can see up here, he H for the 100-inch, the number of the plate, and then another H for Hubble. In 1923, he'd been working 4 years now. 1923, he actually spent 47 nights on the mountain collecting all this data. And this was the year that something surprising happened. Let me read from a passage of my book. October 4th, 1923. The scene was poor, but it was good enough, just barely, to stalk some celestial quarry that autumn evening. As the giant scope swung around, there was a whine, a series of loud loud clicks, and then a final clang as the instrument was secured into place. Hubble examined M32, a small and roundish nebula, for a spell. He then maneuvered the telescope just a fraction of a degree to photograph M31, the famous Andromeda Nebula, the target of choice in the island universe debate. By then, the seeing had deteriorated to a point that other astronomers might have closed up shop. But Hubble persevered, and despite the mediocre viewing, soon noticed a new speck of light within Andromeda's cloudy veil. It was exactly what he was hoping to find one day as he conducted his extensive survey of the nebulae. Novae had been seen before Andromeda. That wasn't startling. But Hubble was sure that additional sightings would help reveal Andromeda's secret. Nova suspected, Hubble neatly wrote in black ink in his logbook for plate H331H. After photographing Andromeda for 40 minutes, he went on to observe another nebula, a barred spiral, before ending his run. He returned the next night and again saw the new pinpoint of light. Confirms Nova suspected on H331H, he wrote in his logbook. Well, here is the actual photograph that he took that night. And once he left the mountain, he took it back down to his Pasadena, California office and started comparing them with other photographs that had been done over the years of Andromeda. And in doing that, he spotted that there were two more novae that were indicated there that he took on the night of October 6th. And he also could see that the one at the top, the novae that he had originally saw, was actually, by comparing them with those other photographs, were coming in and out, brightening and dimming over the years. He had found a variable star in Andromeda. You can see he X'd out the N and put in VAR, exclamation point. So excited he was by this find. It was celestial gold, for here was possibly, just possibly, that cosmic yardstick out to Andromeda directly. What he didn't know, whether it was just a normal little variable star or a Cepheid, it had to be a Cepheid. That's a special variable star, and Leavitt's law only works with the Cepheids. So he started keeping track of the star's variability, started watching it night after night, and 3 nights in February 1924 proved crucial. On the 5th, 6th, over here, 5th, 6th, and 7th of that month, he directly observed his variable brightening by more than a magnitude. It was a tremendous break because from the length of the period and the overall shape of the curve, he now knew that it truly was a Cepheid variable star. A star, a special variable that's thousands of times brighter than the sun. This actually was his moment of discovery there in February 1924. And that is when he went back to his notebook and added a little note right there in the bottom. Here's from my book. Customarily reserved, Hubble at this moment is unmistakably restive. He didn't write his message in black ink, which he regularly did for his records, but instead in pencil. And his handwriting, usually so fluid and precise, was more hurried and askew. He was obviously elated. On this plate, H335H, 3 stars were found, 2 of which were novae, and 1 proved to be a variable, later identified as a Cepheid, the first to be recognized in M31. And to highlight the addition, he drew a big arrow pointing directly downward at his historic news. In its broad stroke, the arrow makes his excitement visible upon the page. For once, Hubble dropped his guard and figuratively clicked his heels at this moment of discovery. Well, Hubble couldn't help but notify his nemesis, Harlow Shapley. They couldn't stand one another. Hubble, but they really needed one another. Hubble had access to the largest telescopes in the world, and Shapley, who is now at Harvard, had access to all the best photographs, the great Harvard College Observatory photographic collection. So notice that Hubble didn't open up his letter with polite niceties. He went right to the point. Quote, "You will be interested to hear that I have found a Cepheid variable in the Andromeda Nebula." And then he went on to describe all the technical details. It had a period of 31 days, varied between magnitude 18 and 19. And here's the kicker. Using the very same formula that Shapley had derived for the Cepheids in globular clusters, Hubble calculated a distance to Andromeda of 1 million light years. We now know it's 2.5, but some more calibration needed to be done, but it was still 1 million light years. No more circumstantial evidence or convoluted reasoning. Here was direct and indisputable proof that Andromeda was indeed a separate galaxy. Well, Hubble got in some further digs at the end. I have a feeling that more variables will be found by careful examination of long exposures. Altogether, the next season should be a merry one and will be met with due form and ceremony. Well, Shapley, upon receiving this letter, held it up in his office and told a colleague, "This is the letter that has destroyed my universe." Shapley knew the game was over. Hubble won. Well, Hubble made that finding in February 1924, yet he held off publishing. Why? Hubble's greatest fear was being caught in a scientific error. And there was a colleague at Mount Wilson, his name was Andrea von Manen, who was insisting that he was seeing spiral nebulae actually rotate in the sky, which would be impossible if they were 1 million or more light years away. So Hubble waited and waited, trying to figure out where von Manen must have gone wrong. And he would have kept on waiting until the very influential Princeton astronomer Henry Norris Russell insisted that Hubble submit a paper to the next American astronomical meeting. And that is what Hubble did. Though in my mind, still a little worried that something might be going awry, he didn't show up. He had Russell read the paper at the meeting. And that was on January 1st, 1925. And so you might say that that is when Hubble officially revealed the modern universe, a cosmos brimming with other galaxies as far as a telescope could see. Well, now, as the textbooks have it, Hubble went on 4 years later to triumphantly discover the expansion of the universe. But that's not quite the way it happened. Evidence that the spiral nebulae were moving outward had already arrived much earlier using this 24-inch refractor at the Lowell Observatory in Flagstaff, Arizona. And it was due to this man, Vesto Slipher, who was first to obtain the speed of a spiral nebulae. He attached this spectrograph onto the 24-inch and carefully obtained a spectrum of the Andromeda Nebulae in 1912. So Curtis was at Lick, and he was, taking pictures of all the spiral nebulae, while Slipher was at the Lowell Observatory measuring their speeds. And he found that Andromeda was moving towards us at 300 kilometers per second. That was 10 times faster than any star velocity then measured in our Milky Way. This was an astounding speed. And he went on, Slipher went on, using the 24-inch to determine the speed to other galaxies by other nebulae. At this point, they were just known to be spiral nebulae. And by 1917, he had determined the speeds of 25 nebulae. This was an extremely difficult task, especially with just a 24-inch telescope. The faintest galaxy required 40 hours of exposure. Could you imagine? He had to go back and back, putting that little, photographic plate back into the telescope night after night after night to collect the tiny little photons were coming from those distant galaxies. And so the results were that he found that a few of them, like Andromeda, were coming towards us, towards the Milky Way, but most of them were moving away, that they were redshifted. The fastest were whisking away at more than 1,000 kilometers per second. This was just an astounding number to astronomers at the time. And by 1917, due to all of this data, he was beginning to agree with Heber Curtis that these indeed were other galaxies. In fact, he even suggested in one paper that they might be scattering in some way. So we had some spiral nebulae like Andromeda that were approaching us, and we had other spiraling nebulae that were moving away. But that's all they knew. The question still outstanding was there a pattern to this? Were they just sort of randomly moving around us? What's happening here? That was the essential question. And that was the question that Hubble took up, teaming up with Milton Humason, a man who started out at the Mount Wilson Observatory as a janitor, but they recognized his cleverness and they trained him to be a telescope operator, and he became one of the best observers at Mount Wilson. His specialty was getting the spectra, just like Vesto Slipher was doing, while Hubble focused on getting the distances. And by 1929, they were able to find that definitive pattern in the flight of the galaxies outward, long known as the Hubble law. Double the distance, double the velocity. What's interesting, though, is that all of this velocity information on this side of the graph did not come from Humason. Humason was only starting on his measurements. All of that data, every single point of the velocity, is from Slipher. And Hubble used this in his 1929 paper without citation or acknowledgement. Slipher deserves half the credit. And Hubble, in writing this paper, had no idea that this meant that this was an expanding universe. He often commented that he left theory to the theorists. The correct interpretation of this as an expanding universe actually belongs to this man, Georges Lemaitre, both a mathematical physicist and a priest. And he predicted what Hubble found 2 years earlier. In 1927, he published a paper saying that the receding velocities of the extragalactic nebulae are a cosmical effect of the expansion of the universe, 2 years before Hubble's 1929 paper. Space-time was stretching outward and galaxies were going along for the ride. He did all this by setting up a cosmological model based on Einstein's general theory of relativity. In fact, soon after, he was very excited to go to a conference where Einstein was there, and he got a hold of Einstein and excitedly told him about these findings. Hubble hated this. And in fact, he told Lemaitre, your calculations are correct, but your physical insight is abominable. Einstein just hated the idea of space-time expanding. He believed at this time in an absolute stable universe. That was his model. A spherical universe, everything in place. Nothing was in motion. So, unfortunately, Lemaitre published this in an obscure Belgian journal in French that no one else read. And once Einstein tells you that you have an abominable idea, well, he didn't go around speaking of it. So this idea just didn't get in the air. That's why Hubble got all the credit and he didn't. But fortunately, in 1930, Lemaitre's paper was rediscovered and given its due. Then and only then was Hubble's measurements interpreted as an expanding universe. And in 2018, finally recognizing this, astronomers renamed the Hubble law as the Hubble-Lemaitre law. And it's ironic. The man who we most closely identify as revealing the expanding universe didn't really like the idea. He would acknowledge that an expanding space-time was the best explanation at the time, but he was sure that, maybe there's another law of nature that's going to sneak in and change that. So he always called, in all of his papers, he always called galaxy speeds apparent velocities, just in case a new law of physics snuck in and changed everything. He never, ever wanted to be caught being wrong. So he always covered himself. The lawyer, he was trained in law and he made sure that he had his cover. And he was a doubting Thomas until the moment of his death in 1953. Take, for example, this comment he made in 1947, a paper describing the potential of the 200-inch telescope on Palomar Mountain that was about to open. And he said, we may predict with confidence that the 200-inch will tell us whether the redshifts must be accepted as evidence of a rapidly expanding universe or attributed to some new principle of nature. To be fair, it was the era of modern physics with quantum mechanics where all of our classical ideas of physics were turned topsy-turvy. And he was afraid maybe that was happening here too. So he was never a fan of the expanding universe, but the Hubble legend lives on everywhere, in textbooks and everywhere else. Historians of astronomy Helga Krog and Robert Smith suggest that this legend was shaped by American astronomers desiring a founding father and a figure around whom they could drape a single version of the history of the discovery of the expanding universe. But we shouldn't forget, and I don't know why those lines are there.
Hey, Robin, can you erase the lines?
We're working on
Okay.
There were all these other astronomers who came before Hubble. There was James Keeler, Harlow Shapley, Heber Curtis, Henrietta Leavitt. But Hubble remains the central figure. And he did open up an entirely new field of astronomy, observational cosmology. Now, Hubble was able only to see a few tens of millions of light years into space with the instruments that he had on hand. He once said, with increasing distance, our knowledge fades and fades rapidly. Eventually, we reach the dim boundary, the utmost limit of our telescopes. What he couldn't imagine were space telescopes, like the Hubble Space Telescope and now the Webb Space Telescope, taking us billions of light years back in time, seeing galaxies just after they were born, after the Big Bang. Moreover, we've expanded our vision with X-ray, gamma ray, ultraviolet, and infrared telescopes, even gravitational wave telescopes, detecting vibrations in space-time from the most violent events in the universe, black holes and neutron stars colliding. It's a whole new universe since Hubble's day, and I can't wait to see what happens next. Thank you very much. Did I do that myself?
No.
I thought maybe I touched something. And I'm open to questions.
Did you bring copies of your book that we could purchase?
Oh, I didn't, unfortunately. I don't have any copies on me. But you're welcome to go to Amazon and buy away.
Books like this that are presented as an adventure story, and this certainly was. Love it. Thank you. I will look for that book.
That was my desire, because throughout my writing career, this has always been a favorite story of mine. I actually, for my senior history thesis as I was an undergraduate, and I wasn't even a science major, I was a journalism major, but I was taking a honors history course, and we were told, do a thesis on any great event in the 20th century. And I was the sole one who did one on Einstein's theory of general relativity. My history teacher gave me an A. He said, I don't understand a word of it, but it sounds important.
I read a book on the discovery of Neptune, and it was presented in the same vein. You know, the competition and the backbiting.
Exactly. I wanted, because there have been a lot of astronomers, historians of astronomy, very serious. And they always, focus so much on the instrumentation or they just say, Hubble went to the telescope, he saw a nova. And I spent a whole week at the Huntington Library in California. This is where Hubble's papers are kept. He was a former trustee of the Huntington Library. And so he kept his papers there. And I spent a week, and I spent a whole day with his logbook, 8 hours. I was like page by page. I just wanted to glean every little bit of information I could get from it and turn it into a story. And that was this whole desire, was to take what I thought people scientists had been writing about this in a very dry way. And I said, I want to tell the personal story behind all of this. And that was my attempt, is to turn this into a driving narrative. Because it always amazes me that, you have all these famous scientists like Darwin and the theory of evolution, Galileo, the first telescope. And here's the man who discovered the modern universe, and yet people, if you ask who is Hubble of the Hubble Space Telescope, they really don't know who he is. So I was hoping to, through the narrative, to turn it into a more compelling story, even though he's not a very nice man. You get to know
I started reading this about a week ago. Really enjoying it.
Oh, thank you. Thank you.
You have a slide with your other publications and how you decided to research them. I mean, we could go look from the list, but just to get an idea of your insight into why you decided to write it would be.
Oh gosh, I could go through. Well, I could go just give a small. My very first book in 1986. I can't believe it's been that long. 40 years? Oh my God, it's been 40 years. Was Thursday's Universe, and Thursday's Universe. And that was, each chapter took you from, from the Milky Way, and step by step, I went out to the Big Bang. And it was on the frontiers of astrophysics. At that time, I was just starting my writing career. And so I focused on what are the latest developments in the frontiers of astrophysics. And I'm very proud of the fact that I was really, when I said frontiers, I was giving you the latest knowledge of things that were just coming out. And 3/4 of that book still holds up to this day. You could read like the first 3/4 and it still holds up. The only thing changing is they now have exoplanets, and back then in '86, all they could see were brown dwarfs. They hadn't yet even begun the search for exoplanets. And of course, the story of the Big Bang has changed greatly with the fact that I had focused on the fact that they were trying to determine whether the universe was going to stop and come back into a collapse or whether it was going to keep expanding forever. They still hadn't seen that the universe was accelerating. So that has all changed. But I did get the possibility of multi-universes in there, and this was 1986 before many people were talking about that. So that was my taking what I had been doing journalistically as a journalist and science writer, writing articles for various magazines and putting it into a book. Then Through a Universe Darkly, that was the first I think it was the first book on dark matter. I did a whole book on the dark matter searches. And I expected that there would be an answer by now, and I'm totally surprised that nothing has changed. Third book, Einstein's Unfinished Symphony. And I was starting in the 1980s, I started covering that for various magazines. And Science 85, Discover. I was doing a series of magazine articles on this. And I had always admired previous science writers who were able to cover the founding of a field. I always admired the great science writer, New York Times writer, Walter Sullivan. I don't know if anybody remembers him, but he was covering the beginning of radio astronomy, X-ray astronomy. And when I started writing in the 1980s, I was always jealous. I said, oh my God, I'm just going to do the cleanup. He's got it all. I can't discover the founding of a field. But with gravitational wave astronomy, I said, gosh, I could get in on the ground floor on this. So I very fortunately started a book covering it in the late 1990s when they were constructing the observatory. So I was able to be there while they were constructing the observatory. I was able to sit down with all the founders of the field and really sit down and talk to them about how this all originated. And fortunately, I didn't wait till they detected, because my book came out in 2000 and they didn't detect until 2015. And in that interim period, a lot of those people passed away. Joseph Weber, John Wheeler, some very important people, Ron Drever, died. And by the fact that I was able to sit down and talk with them while they were building the equipment, I was able to get a far richer story than if I tried to do it later. So then the next book, Archives of the Universe, was something that was requested of me. I had an editor who just wanted a treasury of all the important astronomy papers. So I took that on as a challenge and adored it. It was just a fascinating project where I have excerpts of everything starting with determining the size of the Earth or the distance to the sun back in the old Greek days, all the way to the accelerating universe. And that book is now actually being used in a lot of astronomy courses, introductory astronomy courses, because it really gives you a whole overview of the astronomical history from Greece to present day. Then the next one was The Day We Found the Universe. And I told you that was a long desire of mine to do that. Then I did a story on the history of black holes. There's been a lot of books on the physics of black holes. I wanted to cover, in honor of the at that time, it came out in 2015, the 100th anniversary of Einstein's theory of general relativity. And I was using that as a sort of a celebratory how it took 50 years for the physics community to accept that black holes could indeed exist. And I was fascinated by just the whole struggle to get this idea, which was considered just fantastical and impossible, to full acceptance. And then I did a book of essays. I had done a number of, for Natural History magazine, I was doing a number of essays for the magazine where the conceit was take something that has just been discovered and pull back and show how it was sitting on a foundation of previous work. And for example, when Pluto was demoted to dwarf planet, I wrote a story about Ceres, the asteroid Ceres, that also was once a planet, then demoted to dwarf planet. So, you know, I was trying to show that there's nothing new under the sun, that there's always something you can look back in the past and see how it affected our future understanding. So I put all these essays together in a collection called Dispatches from Planet 3. And my latest book, I'm co-authoring with my husband over there in the corner, Stephen Lowe. We're doing a book that's coming out next year called Star Day. And it's part of a series put out by the University of Chicago Press, where you take a subject and you go through a whole day. Each hour is a chapter. So they have flower day, tree day, you know, and the person is an expert who's writing on it, and they'll tell you what's happening to a certain thing at 1 o'clock in the morning or 3 o'clock in the morning or 4 o'clock in the morning. And my editor really wanted to do something with astronomy that he couldn't figure out. And I said, hey, there's right ascension. You can go from 0 hour to 23 hour, and you can have a whole cover, you know, the whole sky, celestial sphere. So we picked out an object in each hour of the sky, and each has a chapter. So we had a fun time. We're just in the midst of the copy editing process now. But it'll be a fun book, just a small, fun book that it got me into stellar astronomy. I had not really focused on, I've been doing a lot of cosmology, galaxies and Big Bang, and now I'm going, oh, Spica is actually 2 stars that are spinning around in each other and look like eggs. I didn't even know. I had not a clue until I dipped down, and we had a lot of fun uncovering interesting facts about these celestial objects. Yeah. A mathematician.
Oh, I'm a mathematician. I have a PhD in mathematics from MIT, and thesis work on the structure of spiral galaxies, spirals. I'm not sure we came up with a good answer. But anyway, you got me a three.
So touch of astronomy.
Then I haven't really did anything astronomy except talking to her. And work about like speech recognition. Lines cute.
My last question, that the group will allow me, I promise. Is there a project after?
Not yet. I want to take a break. I just recently retired, and I'm enjoying the time off. We're going to do actually we are doing some traveling and everything. So books are a commitment.
I going to take a break before the Star Day book came up. And then once the
Editor.
editor at Cambridge, the University of Chicago Press talked to her, and then this idea came up, and so now she's back in it. I'm in it with her.
Yeah. Well, it was a fun project, and it wasn't as intensive. I could just focus on each object. I didn't have to go out crisscrossing the country and interviewing dozens of astronomers. You could do everything, right at home. That I liked. Because I spent a lot of time, I was on the road a lot with the Day We Found the Universe. I did a lot of archival research in Cambridge, Massachusetts, at Princeton, out to California. Of course, I spent a month in California. So, it's, Arizona. It was a big jaunt, travel wise, to gather all this information.
There's a question from online from Lori. She said, when did they finally change from nebula to recognizing the distant spirals as galaxies?
Oh, interesting. Well, Hubble hated the term galaxy. He felt that was totally meant to be the Milky Way only. He always called them extragalactic nebulae. And it was basically Shapley who decided they're all galaxies. And with his position at Harvard, he had a lot of power that got that going. But for a while there, it was East Coast versus West Coast. The East Coasters would use galaxy, everyone else would say extragalactic nebulae. But after a while, everyone started using galaxy. But yes, that was a bone of contention for quite a while.
So Shapley knew it troubled Hubble. We got one last big.
Oh, yes, probably that was the very reason.
Can you bring back the slide of Hubble and its knickers?
Oh, sure.
It was M81 or M82 still listed as a nebula in all the catalogs?
I'm sorry.
No, I was gonna say, is I think M81 or M82 still listed as a nebula in a lot of catalogs.
Yeah, you learned it 30 months. Then grow with it 30.
M31 is Andromeda.
At 81, 82.
I had a question about that slide.
Yeah, more than, there we go.
I'm gonna propose that we have knickers night, start scouring the vintage shops.
Yeah, he always said there's a famous picture of him leaning back in this bent wood, chair, and he's wearing this outfit. And that was his standard outfit. And if you go to Mount Wilson, they do have a bentwood chair sort of tacked onto the wall, but everyone feels it's not the original. They couldn't trace it back to being actually the Hubble chair, but it's definitely a replica of it. But they have it prominently there because he was known for that. But look at that tie and everything, go to the telescope, work all night, wearing a tie. It was a different era. But it drove his colleagues crazy. I mean, they really all, came from the Midwest farmlands. Harlow Shapley, Vesto Slifer, they all came from the Midwest and had, down home ways. And here's this guy with a false British accent. And he didn't hang around with his fellow astronomers at all at Mount Wilson. He had married a very rich woman, and he hung out with all of the Hollywood celebrities, Aldous Huxley, writers, and various the Hollywood aristocracy. He hung out with them. He was not very well liked at the observatory.
Just say it's great to hear the real story. I kind of knew about Hubble and Hubble's law and stuff, but without knowing anything else, just kind of fill in the blanks on kind of the smart guy figured it out in a straight line without much help. And You know, that's not the story.
Yeah.
So.
Well, the thing is, I have to say, he was very dedicated. He was a meticulous, he really did have a sense of, I don't want anything to leave my hand until I know it's correct. So that was his law profession coming into play. He wanted to nail down every fact before he let it out. He was meticulous in that sense. He was a lousy observer in the sense that he was really, it's well known on the observatory, he was very bad at like going to the dark room and working with developing the plates. He was just really bad at that. A lot of scratches, and you know, he just wasn't the best technical person, but he was very good in terms of the interpretation and the writing up of the papers. So I mean, it's not like he was a lucky man. He did have the wherewithal to recognize a problem, and this is important in science. Spiral nebulae was not really a topic that other astronomers were interested in. It was a side thing. And he saw there was a future there to study the spiral nebulae, where at that time in the 1910s, when he was doing his thesis, it was stars and planets that were the key things that astronomers were interested in. Spiral nebulae were considered a minor thing. Why do you want to bother with them? You're not going to get fame and fortune with that. But he recognized something was there. My suspicion is right before he started his PhD, he attended the American Astronomical Society meeting at Northwestern University. And that was when Vesto Slipher presented his data on the spiral nebulae. I think he was inspired by that to then focus on the spiral nebulae as his thesis. I think he saw there's something here, and I'm gonna put my nose into it. And that was the best decision he ever made.
Did you say it was, so Lemaitre,
Lemaitre, yeah,
was it, you said it was 2 years before Hubble,
yes.
so that was 2 years before 20.
What he did was he gathered the distance information that Hubble had already published, and he actually went and visited Hubble, and he visited Vesto Slipher, and he gathered some of the velocity and distance information before it was like fully out there.
But he wasn't just going off of Slipher's 1917 data, which
He was
just-
using that, he was using Slipher's velocities that were already published, but he also gathered some distance information
Okay.
from Hubble, who had been publishing distances
Okay.
starting in
Some of
19,
those same guys.
yes,
Okay.
and he put them together
Okay.
and developed his own Hubble law, and even came up with a Hubble constant. Well, what we now know as the Hubble constant. He came up with a rate of expansion, far off, you know, because everything was so close to us that it got out of kilter. You couldn't really get a good, didn't have a good set of data, but he was at least seeing the pattern, and he said that it was an expansion, that it was space-time actually expanded, which was, even Einstein didn't believe that was possible, that, you know, no, doesn't make sense. So,
We have another question online.
sure,
So from Bill, said Hubble was the first to use the 100-inch scope. Where were the other astronomers? Today, we have committees at adjudicate telescope.
he wasn't the first to use the 100-inch, but he was one of the many astronomers there had a number of programs. I mean, Mount Wilson, they weren't just looking at spiral nebulae, they were also doing a lot of work in other arenas. Mount Wilson, they had a staff of astronomers that were permanently, unlike today, where many astronomers are university astronomers who then go to a telescope and they, in a sense, rent the time and pay for the time on the telescope, like a Keck telescope or the Hubble's or the Webb Space Telescope. You're getting assigned time where you apply for that time and all. Back in this day, the main way that astronomers did their work, they were actually staff astronomers, employees of the observatory itself. That was at Lick Observatory, at the Mount Wilson Observatory. They all had staff positions. And so the telescope time, therefore, was divided among the various astronomers, and the decisions were made on you're going to get it this night or that night. And so Hubble, because he was looking at the spiral nebulae, he would be using the telescope during the dark nights when the moon wasn't out, so that he could see and get the light from the distant galaxies. The moon would have been a big interference. Other nights, if you're working on planets or nearby stars, the moon is not so much of a problem, and they could continue those times of the observing schedule of the month would be given to the other staff astronomers. So it, like anything, they dickered for their time. And I'm sure, like when he made his discovery that Andromeda was truly a distant galaxy, they probably then made sure he got allotted, or when he saw his, oh God, this is a variable star and I have to look into it, he probably convinced the director and whoever was making decisions about telescope time to give him extra time to watch the Cepheid and map that period and the brightness of the star over time. So they probably gave him extra time for that. But no, he was not the first. He was just one of many staff astronomers working at the observatory and given their allotted time.
Something I've always wondered about this particular area for observing is, like, I can't imagine, this was the one in Los Angeles, correct?
Yeah, just above Mount Wilson is right by Pasadena, California, right outside Los Angeles.
Trying to remember. Yeah, so what can you speak on, like, at that time, like the early, like 1900s, 1910s, 1920s, what was the light pollution like then compared to now? Like, how often were they able to get good, dark, relatively dark sky nights in that area to do the observations?
It was dark back then. This is before Los Angeles had, was becoming the metropolis that it was. It was still, Pasadena was just like a little village. And you didn't have the bright lights then. And I mean, the reason they built the Mount Wilson Observatory in the early 1900s, and one of the reasons was it was a good, stable air, dark, and so it was very good, though it increasingly got worse over time. But at the time that Hubble was using it, it was still fairly dark, and you didn't have, oh my God, you go up there now at Mount Wilson and it's just, it was farmland. It was mostly farmland then. Now you see just light spreading out like it's just an ocean of lights. But back then, all of that was dark because it was just farmland, orange groves and things of that nature. So very different, very different. Though the one exception was during World War II, they had blackouts. And Walter Baade, a Mount Wilson astronomer, was able to do exceptional work because he was, while the other Mount Wilson astronomers were on military duty, taken off, and because they had experience with optics and all, they were put onto military projects. Walter Baade was a German native And he was actually not able to leave the town. I mean, he was being constrained. But he was given permission to continue observing on the mountain. He had the telescope to himself during World War II, during the dark hours, and he did tremendous work. In fact, his breakthrough was he was able to determine that there were two different sets of Cepheids, that each face had their own period luminosity laws. And that's when they were able to determine that Andromeda wasn't a million light years away. It was really 2.5 million light years away, because the Cepheid that Hubble discovered was not the same as the ones that Shapley had used to measure the globular clusters. So by applying that formula, he actually doubled the distances and helped explain a very awkward thing. When you use the original Hubble constant, you couldn't get the age of the universe right. The Earth was older than the universe, and that drove everybody crazy. But once Bod worked out this thing with the Cepheids, it doubled everything and took care of the problem of the age of the universe. And it all had to do with the blackout. He was able to do meticulous work during the blackout when Los Angeles was totally dark.
Did Levitt, Henrietta, did she have both Cepheids in her plot?
No, at that point, she didn't know. She just lumped them all together, whatever Cepheids that she was
Kind of
discovering.
looked like one trend, but I guess if it was really two, that kind of sandwiched the data.
Yeah, it's like,
It looked pretty messy.
I don't know. It'd be a good question
Because
to
those
ask.
were a lot closer.
Yeah,
Right.
you'd think that she would have a few strays running around if they were two totally different ones, but it could be that she was working specifically with a cluster of them within one of the Magellanic Clouds.
Okay.
And it could be that they were all similar because
Yeah,
they
yeah.
were all born in a similar situation, where when Bod was looking at the Andromeda galaxy and others, he saw a whole galaxy's population.
Yeah.
And he was seeing, if you know, there's population 1, population 2, he was seeing Cepheids in different areas of the galaxy,
Right.
born in different ways.
Yeah.
I thank you very much.
Yeah, thank you.